ran it, and then announced it. Remember that? That was my first program, but I didn't have this. I didn't have a good ID for it. I didn't have anything. I did not. I just spent way too much time finding that missing comma. So I said, okay, I'm doing IT. But now I'm back to sort of programming area, and I really enjoy it. The past 2 weeks ago, blatant plug for myself. I finished working for Fabuid, and actually I have a couple of clients, but looking to do DevOps as a service for anybody that might need it. I'm not looking to, like take over your IT, take over stuff, but come in, do what you need, and move out. Anyway, networking basics. Why am I talking about networking? This is like very, very simple stuff. So why am I even mentioning it? What I've found is that a lot of times developers or development doesn't always, your focus is many times on the code. How your code interacts with the rest of the world doesn't always sort of hit production the same way. So I'm just going to go through, break it down from basics, from an IT perspective, what it looks like. They can hear me in the back? Hear me good? You good? A bit more? We're good? This way? Okay, here we go. Everyone can hear me? Okay, fine. Thanks. So I want to just break it down from an IT perspective. What's happening at the basic level, and then moving up through everything. The OSI model is called an IT model. I forgot what it stands for, but it's an IT model for sort of breaking down all the way from the physical layers. All your traffic going over any sort of network is at the end of the day just little either bits of light if it's fiber, or it's electromagnetic waves or something. It's electricity going through a wire. So it like goes all the way down from the physical level all the way up till your browser. What is switching and routing? How you get an IP? Once you have an IP, once you have a way to address your service, how now are people accessing that service? Where are they getting it between public and internal? Your service is hosted internally. Hopefully you have a firewall in front of it. How are people accessing that service? Why is it working? Happen to hypervisors, container networking. It's again similar concepts, but they just apply slightly different in a virtual world. How DNS and DHCP sort of work, meaning this is where we're getting from the IP layers all the way till your URLs are ready. A little bit, I want to discuss it and a quiz, but I'm just kidding.
A joke.
Yeah, there we go, a joke, thanks. Okay, this is the OSI model. I'm not going to spend too much time on it, but it starts with this is how IT sort of looks at it. IT really stops around here, basically, around here. Starts at our physical layer. It says, okay, when I'm troubleshooting something, I'm going to look at it. So many times, this is what happened. I call up, and the client calls me, this when I was back in IT. My first question is, in these words, please don't be insulted or offended. Can I ask you, is your computer plugged in? Or is your monitor plugged in? Or is your network plugged in? Looking back, of course it is. This is how the conversation, well, of course it is. Well, do me a favor, I ask everyone, check. Hey, it's not. That's literally what happens many times. So first thing is, we're going to check the physical stuff. I think Tzvi actually mentioned to me where there was a physical thing. Somebody kept on stepping on a wire. They couldn't access, what was it, a database that kept on blinking?
A couple different stories. No, but one of them was a guy hitting. He was hitting the power strip underneath his desk.
Hitting a power strip. That's another one. Yeah, I've done it myself.
when they made lunch, they would unplug the.
Next we're looking at. Next we go to the next layer, which is going to be. We have something. Our physical is fine. We have something running over. Was that? Oh, all right. We have our physical layer. Everything is checked out over here. This physical layer is going to include our switches, our power supplies, our routers, all the modems, whatever is fiber optic, whatever it is that takes it to be moving the traffic. Next, we're looking at the data link layer, which is going to be Ethernet, switching, bridging, not yet really having IPs. We're on a network. We have some traffic going over the network. How is it physically being addressed? Next one is, now it's logical addressing. We're setting IPs, IPsec, different protocols for how to transfer our logical layer to our physical layer. Transport is now, we're hitting protocols. Now that we already know how to address it, we're hitting protocols. We're saying, okay, do I want to, on TCP versus UDP, for instance, do I want to acknowledge that this packet went? Every time you send out a packet, it keeps on just sending packet, however many, I forgot, it's 64-bit packets or whichever, depending on the protocol. If you're hitting VoIP traffic, it's also being segmented into bits of packets. So what happens here is, for instance, TCP is going to say, acknowledge, did that packet arrive or did it not arrive? TCP obviously has a bit of an overhead because there is always going to be acknowledgement back and forth. Did it arrive? Next packet. Here it is in this stream. This is where it belongs. UDP just shoots it out. UDP is used, for instance, for video streaming, anything that I don't care about the integrity of the packet. I just have to keep on moving something. Session, presentation, and application. This is really, application is not really that. This is why it's IT calls application. It's not the application. It's how the user interacts with your application. Is it a browser? Is it FTP? Is it SSH? However you're interacting with whatever service is behind that. Going one down, here's your connection information. What type of connection is happening here? Is it an SSL connection? IMAP, which is for email. SSH is which is going to give you secure shell. However it is. And this is really, you guys are probably working from here to here, a little bit at this layer.
Wouldn't like FTP be the same thing as HTTP? I mean, whatever, not the same thing, but the same level as HTTP? How's it broken levels? No,
It depends, because you can have an FTP client or you can have an FTP protocol.
Oh, yeah, I got it.
It's how the connection's happening. So I just went through that. I'm going to focus now on layers 2 and 3, which are, now actually this is just a model. It's not like Terry Messina that you have to follow this model. They actually have a new model called, I forgot, it's a 4-step model. When I learned it, they were just coming out with it, but it was just a way of sort of logically breaking it down. So I'm going to be focusing right now on layers 2 and 3. We're assuming that we have all our connections up, right? Now we're at the network layer. Network layer, there's a difference between switching and routing. Switching says, I'm attaching, here's a physical port, I'm attaching a logical address to that physical port. That's called a MAC address. Either it might be a physical port on a switch, it might be a physical port on an end device, it might be a virtual port. Keeping in mind, switching, all that at the physical layer is called the network. Whatever is happening at the network layer. It's saying packet A should go to physical port B. Packet A, and they have something called an ART table, and we're not even touching IPs yet. Routing is moving stuff between networks. I have network A, network B, and I'm saying, okay, network A, I have an IP already. IP is 192.168.1. Or just to make it easy, 10.1. I don't want to have to say it again. 10.1. I know a way to access 10.1. 10.1 network lives on this router. Look at this router for that. That's where the gateway for it is, or an external method of accessing it. We'll get to that in a minute. Then at that point, what happens is network B is 10.2. 10.2 says, okay, I have no clue what 10.1 exists. So all I know is I have a bunch of IPs, and those are my router is telling me, okay, look, IP this is connected to MAC address this. I have no clue where IP 10.1 exists. So it looks out of its network and it looks at the router. What a router does at its most basic form is it moves packets between networks. The same way you could have it at the physical layer, where you're having network traffic happening within its own network. There's a method called VLANs, that you usually run into either in the cloud, where you say VLAN A, VLAN B, or whatever you're naming it. What's happening over there is that it's tagging a port. It's saying either a virtual port or a physical port or whatever it is. It's tagging a port and saying, here's a tag, this is the VLAN it belongs to. Now, any traffic happening between those tags moves along the switch, and again, not the router, it's a switch, happens between, it looks at its group of ports and says, oh, this group of ports belongs to VLAN tag whatever. So now I have the same exact physical switch, but it's not ever going to be routing if, let's say we have a switch, port group 1 and port group 2, it's never going to route between port group 1 and port group 2 unless something says route between that, and I need to have some router in between those two ports, a virtual router of some sort. What are advantages to using VLANs? The easy way is you want to isolate traffic. If you're doing, let's say, 192 networks, we're going to get to that in a minute. The Class C networks, we only have 253 IPs because the gateway doesn't count, right? If you have 253 IPs and you want to make for whatever reason you can't change your IP scheme or whatever it is, then what you're going to do is say, okay, make another VLAN, and now I have a whole another set of IPs available because VLANs don't talk on the networks and switching don't talk IP. They're only talking MAC address, physical port addresses. So that's what happens is your physical port is going to say, okay, I have here a bunch of 254 even virtual ports or whatever, however many devices I have. All those ports are VLAN A. Now I need to have more, so I can say, okay, I just expanded my network, have VLAN 2, put a router in between, and now you have a lot more IP space to work with. Another reason to use VLANs is if we want to isolate a guest network, meaning I'm saying guest network, VLAN A never touches VLAN B. VLAN A is guest network. This also makes a difference if you're going to be putting up DMZs. You're going to put your firewall in front, say VLAN A, and then put another firewall between those two. Here's your internal network, here's your DMZ. This is your sort of untrusted network. You're keeping your, say, your public-facing servers on that. And VLAN A is never going to touch VLAN B unless what you allow through across those VLANs. Another area where you can use it is you have different physical switches that you want to get them all connected up. For whatever reason, they might even be on different networks. So one might be on across a VPN or something. How are you connecting them up? You can that comes in a little bit by containerization by Kubernetes. You can theoretically just say, here's my VLAN, and it spans a bunch of different geolocations, or it doesn't have to be anywhere in the same location. How we covered switching. How does a device get an IP? Switching is we have a MAC address, which is a physical address tied to a port, or it's a virtual address tied to a port. Now you have to get an IP. What's an IP? An IP is from outside your network. How do you get an IP? This starts with a little dance. It says, hey, I don't have an IP. I need one. Again, this is still without an IP. It's sending out a broadcast traffic saying, hey, anybody has an IP for me? Okay. Do you want this IP? Yes, maybe. Okay, I do. Okay, here it is. And whatever assigned the IP keeps a track, a record, and say IP this exists at MAC address, at whatever MAC address is defined.
I think there's only 4 billion IP addresses around, so I don't know if anyone could take whatever.
I get that.
Yeah.
So now, DHCP server is Dynamic Host Configuration Protocol. It's a server, and it's basically assigning IPs dynamically to hosts. Hosts are, again, our physical layer, our logical addressing of a physical layer, generally MAC addresses. DHCP is assigning logical addresses to those logically addressed physical ports, if that makes sense. Now, DHCP, besides for assigning IPs, can also be used for other things. Basically, I have a device on a network that does not have IPs. It needs information. How can it find information? It needs to know, besides for the IP that it itself should have, how does it know where the router exists? It has to know how to even reach out to the internet. if it looks up, for instance, a DNS lookup, I don't know, it ends up, 123.456, no, not dot 456, 123.123.123.123 address, it's on a network that says 10.1. How in the world does that know where to even find a 10.1? So what happens is most things just are going to have a routing table and say, okay, I got my routing table, all my internal stuff are here, anything 10.1, I can look even to my switch to find it. But if I want something else, I'm looking for my gateway. My gateway is almost always going to be the router. And DHCP is telling you, by the way, if you're looking for a router, here's your router. It's on this network. Another thing DHCP, well, for our purposes does, is this is important, is it assigns a DNS server. You need to have a URL. I'm looking for google.com. How do I find google.com? There's no IP for google.com. So what it says is domain name server is saying DNS, here's my google.com. Look at this IP for google.com. And however it deals with the IPs. I'm going to go drop into how IPs are. I'm not going to get very deep into it, but the IP is really divided. It's called subnet masking. It's divided into two portions. One portion is like, if you want to call it, think of it like if you're on a street, at least in Borough Park, you're on 17th Avenue and 57th Street, right, Shannon? 57th Street, okay, fine. So I'm looking, my address is 1751 57th Street. So 17 is telling me that it's between 17 and 18. 51 is actually the house number. This works in a very similar way to this. My 192.129.142.30.56 is divided into two portions. It's divided into network. It's saying what's my network identity? It's 17th Avenue. Okay, fine. And then it says here's the identity of the actual device that it was assigned. So here I have 192.168. That is going to be my my network ID, and then I'm going to have my own local ID, however that might be. Now, how do we divide? How do we know where the identity, where does it stop? Meaning, maybe 192.142.30 is an entire network thing. So that's where we get into class A, B, and C addresses, and theoretically it can be broken up a lot more. Not to get deep into it, but class A's generally have, how much is 254 times 254 times 254? A lot, right? So, about 10,000 something. So class A's.
It's 4 billion. It's 4 billion. 255 times 255.
3 times,
About
not 4 times.
Oh, 3 times.
8 times
Oh.
3 times 2, right?
Okay, I'm not taking my
Or the
calculator.
par-
Anybody wants to take a calculator could feel free to what's it called. It starts off in the other way. We'll go the easy way.
2 to the power 8 times 6.
16
2 to the power 8 times 3.
16.5 million.
16.5 million, good. So we can have IP space. It says, here's my, it's basically it's a 32-bit address. So what happens is I can say how many bits of those are going to be the network and how many bits of those are going to be the host IPs. When I'm saying it's a class 8, it really could be divided up into class 9, class 10, whatever, /8, /9, /10. It's just telling me how many bits are being masked over here. I hate doing subnet masking. Most people I know also hate doing it. You do?
Use a calculator.
You calculate, exactly. If you ever have to do subnet masking, don't do it. But if you ever have to do it, go online and say subnet mask calculator and find it. So basically, it's divided up into 3 sets of addresses. You have your addresses that have 16 million. You have addresses that have 254 times 254. And then you're going to have just 254 itself. No. Now, there are other addresses, and this I've seen people run into the problem. If you notice over here, it starts at 1 and ends at 26. It starts at 26254, that's the last one, and it starts at 128. What happened to 127? And many times we're going to say, it's a 10 dot address, you're looking for it. Why is it 10 dot? Why not 11 dot or something? 192 actually doesn't have that skip. So there are some special addresses that there are some special address sets that are never given out, meaning, what's the name again?
Sure?
Sure,
Oh,
yeah,
yeah.
sure. You mentioned that there are about 4 billion addresses, right? So, all those addresses were given out, the last public IP was assigned in 2011. We're out of IP addresses.
Before.
IPv4. IPv6, this is 32 bits, so we're at 32 bits, so it's gonna be 16 billion times 254 ends up a bit over 4 billion. IPv4 is a 128 bit, it's 128, it's a hex address, so it gives you a whole different, it gives you like way more, and a lot of, for instance, if you on a cell phone, they usually they go ones and zeros, and then it goes A through F, right?
That's hexadecimal,
Yeah, right, so you're going to see many times that when you get an IP on a cell phone, you're getting only IPv6. They're not even bothering with IPv4. Your cell is actually publicly exposed to the internet. You're getting an internet address on one of trillions of addresses that actually have publicly exposed without a firewall. But you don't really have to worry about it, because I don't know if anybody's gonna find your address, but I honestly, I never worked with even DNS addressing on IPv6, so I don't know many people that are, but it usually happens at the layer past your own router, past your own internal networks.
Who's assigning the IP on the phone?
What?
Who's assigning the IP on the phone?
Verizon.
Verizon, when you get the phone, when you first sign up with the service, you get one.
No, every time you connect, every time you connect to the network, you
Will
go
it
back.
flip when you go from tower to tower?
Potentially, because every time you get into your network, you don't have an IP. You're just connecting to them. You start this
They're
dance. Oh, I need an
DHCP,
IP. I need an IP, and then they go and they say, okay, I need here's an IP.
You do the
for you."
lease every single time you jump to a new tower?
I don't know the technicality, but theoretically, if you're off and you're going to a different thing, I don't know why they would do it, but theoretically they could.
Well, so
Meaning,
it could work like
if
mesh
you're
networking.
disconnected, there's no reason why you should have an
It
IP.
could work like mesh networking, where all the towers all connect to a single
It could be it could.
cable.
You're right. So
And
I'm
if
saying
you
I don't know.
keep these as you
Even
pass them
the only reason to reassign an IP would be if you ran out of IPs.
Oh, yeah, the
I mean,
whole country is one mesh network.
It could be.
Could
The only reason somebody would take away an IP from you and say, okay, I'm reassigning this IP to another device, is if you ran out of IPs. But since we're on 128, or some trillion amount of IPs, I don't see why there would be a reason to even do that.
Are those IPs publicly accessible, or it's behind?
No, I mean, it
So
depends
like
whatever router Verizon put behind you.
So
There's
that
no
might be an
reason it shouldn't be
internal-
public. What?
It might be an internal IPv6 address.
Oh, so, okay, there are a couple of address spaces that are never given out. By the way, I just heard yesterday about somebody that has a Class A address. Yeah, well, they got it back in the 90s or something. He sold it to.
Public?
Yeah, Class A. I think it was maybe the 11. I don't remember which one. He rents it out. It's worth a lot of money. Every Class A ad.
Who cares? Well,
Because if you're being assigned a public IP from I don't know, like 11.12.13.14, how does that exist? It's already assigned to, so it's already given away to somebody else. You can't use it. Somebody controls the routing to that address. That we ran out of addresses in 2011. They gave out the last one. So I forgot who it was. Somebody mentioned to me that, oh, he heard of so and so that actually bought like an IP address space back in the 90s or something. Rents it out. It's a good business.
It's only worth money until IPv6 is adopted, more broadly.
So basically,
Still a while.
25 years.
Still a while. I wouldn't mind having one.
So you're still gonna address this question?
Isn't there a MISA now 4 billion devices that connect already? Like, how do the MISA we do the, it's not clear to me how we have.
the
like
whole
4
Africa doesn't use
not-
it.
No, it's just,
billion?
we don't use them all. How do we use them?
Meaning, how does your server, which has an internal IP, and you have,
No, not internal, external IPs.
yeah,
Not
they're
everything in your house
all
is
either
external.
assigned or given
Your
out.
modem it has.
Why
Right,
is
so how
AWS
let's
so
say
quick to assign?
AWS, they got an IP, right? Where
Because
they
they have
They
an
own
address space,
it.
they own a ton of
They-
address
Why are
space.
they
Assign it.
so quick
If you
to
go on
give
an
them out?
app now, what?
Why are they so quick
They're
to
on
give
the
them
app.
out?
You pay for it.
You don't own it.
But we're not paying for it.
At some level, you're paying for it.
It's so cheap.
Right, but for instance, Optimum isn't, if you unplug your Optimum modem, you have to switch your IPs. You're doing proxying, you're doing whatever, any stuff that you need to change your IPs constantly, and you have IPv4 addresses, on Optimum, it's gonna take it away. If you disconnect from Optimum, they wanna reuse it for something else. They don't wanna keep your IP like, okay, here it is, for this modem. They're going to disconnect it, they're going to take away your IP, and then when you reconnect, it's gonna give you a brand new IP. Because they're
You
working.
could request static IPs, I think, from them,
And
but
you,
generally.
and what happens, you pay for it.
Right.
You pay for it, exactly, and it's basically you're renting an IP from them. That's exactly why somebody's making a lot of money on some Class A space. He has, 16 billion addresses to give out, 16 million? What was the number?
Yeah, 16 million.
16 million addresses to give out. There are a couple address spaces that are never given out. I'm just going to focus on the ones that are very common. The 10 dot, I missed one here. There's the 10 dot, anything 10 dot is never given out because it's never going to be publicly routable. 127 dot, 127, I missed that here. 127 is always, it's a special address, it's always your internal address. 254, I think, is always a broadcast address. And we have here another two of them, 172.16 and 192.168. This is the famous one, 192.168. That's something. These are never given out, and that's why those are reserved for your own routers to assign to you. Router, whatever your DHCP, whatever's doing your assigning your DHCP. There is one other thing that you would want to probably look out for. I'm like, hey, I can't access the internet. I remember seeing this on somebody reaching out on probably was a container on the from devs. This was a while back, and I'm like, this is so simple. What's your IP address? 169.254. Whatever. I'm like, wait a second. That means it doesn't have an IP address. What happens when a device can't reach a DHCP server?
Self-assigned.
What?
Self-assigned.
That is a self-assigned address, and the self-assigned address that always uses is 169.254. And since your DHCP server is usually also telling you where the meaning if you can have a bunch of self-assigned addresses, 169, you have a bunch of devices with self-assigned addresses on the same network, they're still going to be able to talk to each other because they know where the 169 address space is. It's on this network.
Well, why are they not colliding? How can you have two devices?
They may very well, but it's just
And then what
it's so wide. You have here how many thousands of IPs?
It's chosen at random when you
Chosen at random,
self-assign, it's random.
Yeah.
That's a cyber attack, though, you do that.
What?
Pretend you but he asked us now, the collide.
Theoretically they could. Theoretically they could. That's why you don't want. That's why you want to have another reason why you want to have a DHCP server and not self-assign your own addresses. You run into problems when you have two DHCP servers. You by mistake turn down the DHCP service on a different thing, and then you have two things actually the assigning addresses colliding, not knowing. But the important thing when you have a private address is the important thing here is that you don't know where your gateway is. Because part of what DHCP does is it's showing you, oh, here is where you reach out to the world. If you don't know where to reach out to the world, then you can't get out. So when I saw that on the from devs, I'm like, wait a second, that's a 169. You're missing your IP. And it's like, no, it's saying 169. And I'm saying, no, you don't have that. I think it was Passive Chaim Fried responding or something. No, you're missing something there. Okay, once we have an IP, we know where the gateway is. How do we finally get out to the world? Here is your server. Here is your fancy service. We just built a beautiful thing. How does Yankel Schmerl or John Doe get from his network to your network? Now, like could be somebody mentioned here, we have a problem. Your networks are 192.168. This external network is going to be 12 dot. They put a 12 dot over here. How does he know how to route to 12 dot? Before we're getting to numbers, before we're getting to names, how do we know to route to your service? And not only that, so somehow you figured out that it's over here. It's 12 dot. How does 12 dot? He comes to 12 dot, whatever, 12.1. How does he know that your website is sitting on 192.168.1? Maybe it's sitting on 192.168.2 or .3 or .1 or on 10 dot or whatever. How does he know that this should go to here? Something called network address translation, which is literally just what it stands for. It takes maps your public IP to a private IP. It says that's called natting. It says, oh, you're looking for 192.12.1. Okay, 12.1 exists by 10.1. Whatever. Let's skip the full IPs. But 12.1 exists by 10.1. When you're coming from outside, 12.1 is routable. Now it goes in to your server where your website exists. And now, what happens if you have multiple services behind that? And there's two types of natting. I didn't put it up. There's one-to-one. That's a very simple natting, saying, okay, nat move from 12.1 to 10.1. What if you have one-to-many? How does that happen? You can either try to define it by different things. One of the ways of doing it is by saying assigning a port. Port, let's say, what's the default port? 1433 for SQL. So if you're looking for your SQL server on behind 12.1, it says, okay, which port is it? Oh, 1433. Okay, your router is saying, okay, port 1433 is at an address, and your router, besides for usually it's going to be the router or the firewall or whatever it is going to translate and say, okay, you're looking for this. You're looking for port 1433. You're looking for port 443. Are you looking for port 80, which shouldn't be used anymore, but it's probably still being used unless you're doing a redirect, and then it could be used. Whatever port it is whatever service it is that you're hosting your service on. Now theoretically, you don't even have to say port 1433 should go to port 1433. I could say port 1234 should go to port 1433 as long as something knows to translate that from external to internal.
So what about having multiple web servers on port 80
You
behind
can't.
one?
The only way there might be one or two ways to do that. That has to happen at the well, in IAS it's called you're doing binding. In Apache I think it's called virtual hosts. I'm not sure. Basically what happens at that point is you're going to say all your port 80 traffic, or whatever port you're going to be using, let's say 443 because I like that better. All your 443 traffic is going to this IP. Now this IP says, okay, what's your header? Take a look at say let's say I'm going www.fancysite.com should come to this service on my server. I'm serving multiple services, and then you're binding your URLs. It's not happening anymore at the port level. Sometimes you could also specify a port for your service internally if you want, but there's no real reason to do that unless you want to continue splitting up. But I don't see. I mean, once you're doing it by URL, I don't see a reason to start patching it with ports. Up until now, we handled the actual IPs. Can you wait? Up until now, we handled the actual IPs. We're saying, okay, addresses are, okay, here's where our address is, here's how you access it. How does that turn into from your www.mygreatsite? Did I use my fancy site before? My great site. What? What should I use?
Qualitybath.com.
What? Qualitybath.com. There we go. www.qualitybath.com. How do I find qualitybath.com? There's something out there called an IP. There obviously is an IP for Qualitybath. Where's it hosted?
The Heroku.
Heroku. So they obviously gave you IPv4 or IPv6. What?
No.
They're giving you a range, and they keep on managing. Okay, so they're managing your routing
They
too.
give you a CNAME point too, and they just rotate it behind the scenes, and
And they're practicing behind their proxy. Got it. I'll get to. Well, not really gonna get to that part. So basically, you have when you have qualitybath.com, where does it exist? Client out in wherever wants to find qualitybath.com. His client has qualitybath, and it's sitting on Heroku. How do they find it? There has to be something that says, okay, you're looking for a URL. This is where the IP. This is where it lives. Here's the IP for it. That's called a domain name server. Now, usually the DHCP is going to assign a domain name server and say, here's your domain name server. Whatever you most routers by default are just going to do their own DNS query, own DNS resolving, and whatever they don't know, they send it out to the next DNS server to find, oh, I don't know that. Where's my next DNS server? You can also assign whatever DNS server you want. Okay, so let me take you through DNS over here a little bit. At the most basic level, a DNS is just saying, here's my URL and here's the IP. I'm sure many of you have played with the host files on Windows. If you're a Mac, you're lucky you don't have to play with it. There is a host files on Mac. There is a host files. I'm not that familiar with Mac. It's always a host file. Host is your original when they had the DARPAnet. That was your original DNS. DNS didn't exist. There was no domain name server. So it says, here's your URL. Goes to this IP because there simply weren't that many URLs that even existed. What started happening when you play with your host files, many times your antivirus is going to eat it up. Why? Because viruses would go and switch an IP, let's say to google.com, and just point it to their own IPs and do whatever they wanted at that point. A DNS request starts off like this. It starts at a local machine. It says, I have a cache. It looks, generally there's almost always going to be a cache, and it says, I don't have to look this up. I have here a cache of, I might even be able to bring it up. Nah, not right now. It's DNS, whatever. Basically it starts with its own local cache. Did I ever look up this IP? Oh, I didn't? Oh, this URL, I didn't? Okay, let me ask if there's a server that I was already assigned, that I know which server may potentially be doing IP resolution, domain name resolution. In your local machine, it's most of DNS works on caching.
Caching the browser also? Is the browser doing DNS caching?
Sometimes. Some browsers, sometimes. Get to that part in a second also. There's how does the domain resolve? What's the process? It starts there's a couple of. It starts at the dot. At the end of every .com, you never knew this, but there's also a dot. Those are called root name resolvers. You know that? Oh, good. You're advanced.
That's how you get around some filters.
Oh, I'll give you a better word in a second. The dot is your root name resolvers. I think there are 12 global root name resolvers. They're sitting in universities someplace. When you have a DNS request, it's not in your own cache. You look towards whatever DNS server you're assigned. It's going to say, okay, maybe it's in that cache, or let's say they have a record for it. If it's not there, it goes all the way back to the dot. Okay, now we're at qualitybath.com dot. Well, the dot servers don't know where qualitybath exists or www.qualitybath exists, but they do know where com exists. So they keep on going back. Here's a bunch of name servers for the com namespace, and oh, it's not okay. Fine. So now, servers for the com namespace may look for an authoritative name server for qualitybath. Your qualitybath authoritative name server is generally coming from your registrar. When you're going to register a DNS, you register a domain. You're also going to say, and by the way, here's my domain, my qualitybath, not fancy my domain, qualitybath.com. Now, if anybody's looking for it, here, use these DNS servers, and then you can host your own DNS server out there. I don't recommend it. Or you can host, or you can say use Cloudflare, use GoDaddy, use which one do you use? Not GoDaddy. Not GoDaddy. Don't use GoDaddy for almost anything. Don't use GoDaddy for almost anything. Or 1.1 or many different things. Now, what they realized, first of all, I think the first places that started doing this was viruses. They said, hey, people are looking for a URL. Let me see if I can sort of manipulate that and point them someplace else. They're going to think it's this URL, but it's really going to be a different URL. When they realized that, I think the first, not DNS filter, there is a service called DNS filter. What's the other big one? OpenDNS. OpenDNS. I think they were the first ones to start doing that and saying, oh, you're looking for this? Point it to my own servers. I'm going to serve up something behind you. I'm going to tell you, eventually I'm going to tell you. But if I don't like what you're doing, then let's say it's a site that you're not supposed to be accessing, gambling, then I'm not gonna point you to it, I'm gonna point you to a different site which has a page, a block page, and that's literally just how it works. It's almost worthless. Another reason it's worthless is because it's actually not inspecting any traffic, it's not doing anything like that, it's just playing around with your routing. Another reason it's worthless is because of the newest thing called DNS over HTTPS. Generally, DNS runs on port 53. It's an unencrypted query to your DNS server. Amazon has Route 53, which is their DNS service. Theoretically, you can put that on any port. If you have a hosted DNS server anywhere, and you say, I want it on port 54, on port 33154, then you can, as long as you're accepting traffic on that port, then you're fine with that. And your port is again going to translate into your server, and the server is going to respond to whatever request. Okay, port translation, let me tell you, is a little bit more than just responding to that, because it eventually assigns itself its own ports for the communication, because you can have more communication coming in back and forth. The newest thing in browsers, if you're running into a DNS issue, is DNS over HTTPS. These are encrypted DNS queries. It's at the browser or application level. So it doesn't even go through your DNS. If you assign a DNS server to, say, whatever it is from DHCP, if your browser, Chrome started doing it last year, 2 years ago, I think Firefox started doing it even before. By now it's pretty universal that by default, your DNS queries are going to an encrypted going over encrypted connection over port 443. Nothing is really, unless you're decrypting your traffic, nothing is seeing it until it hits the DNS server, the DOH, which is the DNS over the HTTPS server. So that's going to bypass a lot of things that you're running into with that you're trying to manipulate your traffic by using DNS.
You can't force it to go to OpenDNS? The browser?
You have to
You have to go into the browser itself. The way you would do that is either by group policy or by Chrome. If you're doing Chromebooks, then you'd be using Chrome policy. There's some policy to say don't use this DOH server. Use a different DOH server. Another place that comes into play. Or doing USP DOH period, right? I think at Fabio they shut it off DOH. The other place it comes into play, DOH, is if you're if you're routing internally, it could mess up, because if your browser is looking for a DOH server out wherever, you have an internal DNS server. Generally, if you're hosting your stuff internally and you're trying to access something internally on an internal IP, then that DNS server is not out publicly available. So how is your application that's now looking to an external DNS server finding your internal application? That's not going to happen. Couple of if you're running into DNS issues, generally just try clearing the cache. There's another thing called TTL. When you're setting up DNS, you want to make sure that the TTL shouldn't
time out.
or sometimes you do want it to time out so they refresh a little bit quicker. DNS types. A record is straight DNS to IP. CNAMEs are URL to URL, which then gets translated to IP somewhere further back. MX records are mail exchange records. Those are going to be telling you, I have traffic coming on, mail traffic coming from wherever. Where does that server exist? You might run into it with SMTP. If you're going to be setting up somewhere in SMTP, you want to make sure your MX records, so that people should be able to access, or in IMAP, whatever server that you're getting, hopefully is going to have the MX record set up good. There are a bunch of different records. I'm not really going to point it to now. That's all at now like sort of getting to the meat of it. Now that we like have a lot of how traffic is moving from one to the other, now I have here a virtual machine host. I have a bunch of virtual machines, and it's also going to be pretty similar to what we were doing before with the port and address translation. What happens is the hypervisor is going to create virtual ports on it. Whatever software it is, exposing a virtual port to your virtual machine. And those virtual machines can be addressed to the external layer somehow. There are a couple different ways it gets addressed. You can have, I'm gonna skip that. You can have bridge networking, which is, these are just basics. There are somewhat more complex layers, but these are general basics. You can have bridge. It's saying it puts up a virtual NIC on your physical network. Now your VM is physically exposed to that network, and however it gets IPs and routing is however your host network is getting those IPs and routing. You'll see it when you get an IP from your host network. A different way to do that, you can NAT it the same way we can do NAT at the physical layers of moving between networks. You can do NAT at the virtual layers. You can say, okay, here you're looking for something. My virtual machines have their own internal networking. You're looking for service X or virtual machine X. Look at it at this IP. And the hypervisor, whatever is on top of your virtual machines or under your virtual machines, is managing your traffic in between. Sometimes you might not want to expose your virtual machines. You're running a dev network. You're doing whatever it is. That stuff you would probably keep behind. You can say, okay, my networks should not be exposed past wherever. There is no gateway. There is no router. I do or don't want to expose it to the actual host. Maybe, maybe not. Then you're going to generally see private IP. Container networking. Surprise. Well, first of all, disclaimer. Don't shoot the messenger. Well, don't shoot me. I haven't really worked with containers yet, but from the research I did, from what I looked into, it's essentially, again, very, very similar to VM networking. And VM networking, which is just virtualizing our physical networking. It says, if I'm going to do a Docker network read, NAT, what happens? It's saying it's NATing it. Give me an IP, an internal IP, and send it to external. I want a transparent network. That network create transparent. What's that going to do? It's going to say, okay, put me on the physical network somehow. I'm not sure. Very similar to what we had over there with bridge networking previously. We have a bridge network. Over here, they're just calling it transparent. And most probably different, say VMware Tanzu, or everyone's going to have their own naming for it, but conceptually, all the same type of thing. When you're going to have, this is going to be slightly different. Overlay, remember when I spoke about VLANs being able to aggregate across many different many different geolocations? Overlay is doing the same type of thing. Whatever your orchestrators, whatever's running your containers, Docker Swarm, Kubernetes, VMware Tanzu, whatever it is that's going to be doing that, it's saying, okay, pull my networks not from this particular internal network. I might be throwing up and down containers. There's one set of containers here. There's one cluster of containers here. These are all the same network. I'm pretty sure that's what the overlay networking is. I'm not really going to go through this now, but if you're looking for on Windows, I know it. On Linux, I would have to look it up. Very simple stuff. You're going to start with you want to check if you have an IP. How do you find an IP? IP config. I'm pretty sure on Linux it's IF config. Right, same type of thing. If you're going to now, can I access service A? I'm looking for something. You look, okay, ping it. Or on ping is the same on Linux, right? Then there's path ping. That's something else. Ping is always ping. I think Linux had some better tooling on troubleshooting. I forgot what. Could be a trace route or something. Now, is it what? It is trace route.
Trace route.
But you have that on Windows too. Whatever. I'll look it up after.
It's actually route.
Trace route.
Right. So command.
Trace route. Oh, it's not trace route.
No, on Linux.
On Linux it's trace route, and on Windows it's trace route.
It's the same thing.
It does basically the same thing, but ping, you can actually ping either an IP or a URL. Now if you're troubleshooting something, you're going to say, okay, first let me check my lowest layer. I'm pinging something, and can I find the IP? Can I access the IP? I'm going to get a response from the IP. Once I could, okay, ping the URL, because that's going to force a translation. It's going to say, okay, can I translate it or not? Traceroute does something interesting. It's going to ping each hop on the way and give you a response from that. So you can actually see if you're going to do traceroute Google.com, it's gonna go first to quality, if we're on here, it's gonna go first to quality bath router, get your response. You're gonna go out to the Verizon or whatever, Optimum router, get your response, and it's just gonna keep moving away, and it's gonna help, it helps you like find each step in the way where something may have broken down. NSLookup is once you have a URL, something's messing up, NSLookup is, you'd have to do, I don't know, what's NSLookup on Linux? I don't know. Dig is also a similar concept where you're going to get all your information about your URL. PowerShell, this I happen to like, is testnet connection, and it gives you a lot of different good. I can test against a specific port. I can test it against URL. I can test an IP. Now, when you're in an Azure web app, I'm not that familiar familiar enough with the AWS stuff, but when you're in an Azure web app, an Azure web app is essentially a container that that they're just exposing like some sort of interface to those containers. They lock down very heavily those containers, so you shouldn't be able to touch stuff and manipulate stuff. If I'm not mistaken, last year it was, somebody figured out how to get into the underlying layer of the Azure stuff. Yeah, they got it. They ran some stuff and they got in. They figured it out. Now, what they do, you can't run ipconfig, you can't run ping, you can't run a lot of these commands. So they give you custom commands, which is going to do TCP ping and name resolver.exe, which is doing very, very similar. It's going to test the host name, the IP address. This is basically there's different tooling available to you for your troubleshooting. And the testnet connection PowerShell always works. Crunch time.
Oh yeah.
That was a joke.
Waiting.
It's not a joke anymore. Question. This is a simple one, and I've had it. Web designer sets up a brand new website, not qualitybath.com. That was done right. And client calls you up saying, "Hey, my emails aren't coming in. What happened for the last 2 hours?"
You unplug the server to make lunch.
What?
They didn't migrate over that next
Computer was off.
They didn't.
Messed
They
over the
not only
SSL.
they didn't migrate over. They shouldn't have been touching the DNS server, the MX records. All they should have done is put in an A record to whatever IP it is. What happened in that case was the developer actually switched over the entire DNS server and says, "Hey, I need a record, A record, URL goes to IP this. Oh, I'm familiar with GoDaddy. I'm familiar with GoDaddy. Let me just put it into GoDaddy. She had the registrar stuff or whatever it was. She just switched the name servers to GoDaddy and put in an A record. Beautiful. My website works. Turns out that she shouldn't have done that because she didn't migrate over the MX records and the C names for the auto-discover and whatever else makes the emails work. Okay, this I really gave you a little bit of a hint on that. I have an Azure web app. It has to access an on-prem database. Used to work, stopped working. What are my troubleshooting steps for that?
Check the plug on the server.
No, this is Azure. Oh, I'm saying, okay, fine. Yeah, you're good on that. We checked the plug. Plug's plugged in. That's our physical network. We even checked the networks. The lights are blinking.
You still lay out with certain firewalls?
What?
You still lay out with
Good point. Next is we're looking at firewalls. But how am I troubleshooting this? Everything internally it works. I can access my database. I go check port 1433. I can access my database. But those are good steps. What's my next step? What?
Assuming that your database is publicly exposed to the
It's not publicly exposed because I would never expose my database publicly. Let's say it's a VPN. Good.
So then you have a local IP.
What? Correct.
So assume that your VPN is connected, then
We
check
check
if you
that.
can access the IP.
Good point. Now, in my case, it happened. I was able to access the IP.
Could be the IP can't access the database.
What?
The IP can't access the database.
I went into my Azure web app and
Your server can't
I
access
checked
the
my
database.
ping. I checked my ping from my Azure web app to my on-prem server. To my on-prem database server, ping worked.
What about the firewall?
Well, it's pinging, so it's fine.
Just
Okay, good
just
point.
find
Good,
the
no,
guys
good
who
point.
do
No,
it.
good point.
Doesn't
Yeah,
work.
no, he's on to the next thing. That's a good point. I checked my ports. Works again. 1433 is open. I can ping. I used test.net connection. I used NS resolver, TCP ping. It's working. It's open.
And you could
Come on, you're almost there.
You access, you're accessing, what do you mean you can't access, you do access.
My web app isn't accessing it.
What,
It
what do
just
mean
did,
doesn't
you just
have
said
an
it.
My
access?
web app is not accessing it. I'm troubleshooting it from my web app. My console on the web app, I can access it, but the web app itself is not addressing it. Next step, come on.
Okay, I'm not configured, someone said.
What?
It's not-
DNS?
Maybe the app is not configured.
It is, the connection string, I checked the connection string internally and externally. What? No, one more step.
You fail, you fail.
You fail at once?
Stop this.
In this case, it was local DNS. Local DNS I could not ping my local DNS. I put a connection string in the web app environment variables. The connection string is a name, right? It's, let's
But
say,
using DNS.
server A dot, SQL server A dot, something dot local, okay? SQL server A dot something dot local, in order to resolve that local, I need to have my DNS server, which is local to my,
Web app.
which is local to my, not to my web app, but my web app has to know the DNS server that is able to resolve that local addresses. That local addresses aren't external.
Don't use that local.
I know, and I know, it was a big thing. No, Microsoft used to recommend using that local for the Active Directory. They stopped it a long time ago, but there are many different old Active Directory locals. What happened is, even though I can access my my SQL server, my database, the DNS server that was serving up the server A.domain.local wasn't accessible. They had changed something. They put it up on a different network, and VLAN shut down. That I wasn't able to do. This is a sort of a giveaway. Somebody ran into this issue. If they happen to be listening, this is how you do it. This is how I would do it. Azure service. It's hosted in Azure. Let me use this. Here I have service. Connecting to many, many different VPNs. We don't want to expose it externally. Here are client VPNs, okay? How's the developer accessing this service? These are networks. These are client networks, okay? Client over here has to access this service. We can give him an IP now. At this point, I'm getting a 10 dot, right? And over here, let's say my router has two sets of IPs, 192, and it knows that 10 dot go out to there, okay? So I'm over here, when I'm looking over here, client computer, it's a very nice computer, has a 10 dot, it knows, oh, 10 dot, go to here, oh, it doesn't go out to here, here's my 10 dot. Now, how do I do it when I have a URL? I don't want a 10 dot, because I don't want to give your client, you want to give him, this is going to be fancysite.com. You don't want to give him, oh, go to 10 dot something dot something. Your end users are never going to go for that. How do you get to site.com from here? Keeping in mind that this is private. This is not exposed publicly. How do we do this?
I'm saying triangle DNS.
What?
Does not manage
Internal DNS.
I don't manage this DNS. I can't touch it.
Just edit the host file?
You're
You can
editing
still
all your
have
clients'
public
host files?
DNS that points
I'm
to
not gonna
internal
this thing.
IP.
You can expose public,
I
exactly.
just found.
What?
one.
No. You don't want to expose
You can
public.
set a local IP in public DNS. There's nothing stopping you from doing that.
Correct. But some people couldn't figure that out. I'm glad you guys got
I
that.
just came
You
across
just
that.
came up with that. So I was using a slight version. I was using a slight variable the other way around. But I wanted to access stuff here that I didn't want to expose publicly, but I still wanted to have a URL. So I put up a public DNS with a .dev, whatever it was, and I put an A record to my locals.
Everyone's doing this. Why isn't there like just this public service that says, hey, here's the old private IP addresses and a DNS record that
Because
maps
you
each
can't,
one.
you can't route to this private IP address.
No, a DNS record that points to a private IP.
You could do that,
Cause you
but
want a custom domain.
you want a custom domain.
However,
Why is that?
I'm not getting-
Oh, because this client you wanna have.
Yeah,
a
this
custom domain.
client, only this client should be able to access it. So,
So you're-
that's that, I hope it was helpful.
any client, anybody can access the DNS.